Hi. In this problem, we are going to be looking for the area of any polygon inscribed within a circle of radius 1. I decided to solve this problem by using right triangles and special trig ratios. I started by finding angle by using an angle theta. Now we'll discuss how to find theta later, but for now we can say that this length, this side length right here, this side length can be represented by sine of theta. This side length right here can be represented by cosine of theta. Now we know this because if we were to assign, say, cosine of theta, we were to assign that side length to be length x. Well, we know that cosine of theta is equal to x, this side, over the hypotenuse, 1, x over 1. Any number over 1 is just the number, so cosine of theta is equal to x. And so we can just say this side length is cosine of theta. Same goes with sine of theta. So from there, we can multiply the two together now that we have these side lengths. We can multiply cosine of theta by sine of theta. By doing this, we're given a rectangle with an area that you can find by multiplying a base of cosine of theta by height of sine of theta. Now, normally to find a triangle, you divide its base times height divided by 2. Instead, we can just say, we don't have to divide it by 2 because we can say that this is 1/2 of a rectangle that is completed by this. And that cosine of theta multiplied by sine of theta really gives us this section here. Now that section is 1/3 of the polygon with 3 different sides, or 1/3 of a triangle. So we multiply it by 3, and we get the area of this polygon, the area of a triangle, cosine of theta times sine of theta by 3. Similar situation with a pentagon. Create our right triangles, assign our theta. So we know that this side right here is sine of theta. We know that this is cosine of theta. We multiply the two together, cosine of theta by sine theta. That gives us this entire section. Multiply it by 5, 1, 2, 3, 4, 5. 5 sections, and you get the area of a pentagon. Now, the area of the pentagon is the combination of cosine of theta times sine of theta for 5 different sections. 5 different sections, 5 different sides. 3 different sections, 3 different sides. So it seems that the number of sections is the same as the number of sides. So we can say that n, representing n, is equal to number of sides. So we know that n times cosine of theta times sine of theta gives us the area of any pentagon inscribed within a circle of radius 1. Now, to find theta, we used theta to be, we found theta to be the half of the interior angle of any section, or of a section of a pentagon, or a polygon. So we can find this by saying that 360 degrees is the sum of all of these interior angles. 360 degrees in a circle. So 360 degrees, to find one of these sections, we divide it by n, or the number of sides. So if this is one side, we divide it by n, we get this one section. Now we want half of this section so that we can have a right triangle. So we divide it by 2n, so that this is divided in half again, and we get this angle, theta. So 360 divided by 2n is equal to theta, and then cosine of theta times sine of theta times n gives us our area of the polygon inscribed within a circle of radius 1.